Cenergy Solutions' mission is to replace gasoline and diesel engines throughout this country and throughout the world. There's no reason for any vehicle or engine to be running on gasoline or diesel when they could be running on either electricity or natural gas. The testing we do here has to do with activated carbon and how it reacts to cooling and heating.
Let me show you the activated carbon that we're using for our application. What we have in this container has about 10 football fields worth of storage. When I shake the material, this void space up above the solid is now filled with particulates. Now, adsorption is a surface phenomena between the liquid or the gas, a gas in our case because we're adsorbing methane. And this carbon has a number of different pores on it. It has very tiny pores called micropores, it has intermediate pores called mesopores, and it has very large pores, macropores. Generally, in the gas situation where we want to absorb a very small molecule like methane, we want lots of micropores. And we can control the adsorption and the desorption with heat. You'll notice that it's kind of a steady state relationship between the volume of methane stored and the pressure that's developed in the tank. The second graph is using absorbed natural gas. We talked about these micropores. In the first part of the graph, we're filling micropores. And then as we get out, we start acting like compressed natural gas. Here at 30 bar, we have much greater quantity of natural gas stored in this system than we do in compressed natural gas system.
The benefit of adsorbent natural gas makes it so that you can fill up your tank at home and at your business. I have been able to fill up an ANG vehicle, this test vehicle, at my house with a low pressure compressor. Everyone will be able to do that in the future, either at their home or their business. They'll be able to fill up their vehicle with natural gas that only costs somewhere between 70 cents and $1.20 per gallon, a lot less than gasoline or diesel.
This is our first generation experimental test vehicle. As you can see, we have a CNG tank packed with adsorbent carbon absorbent, which we are trying to heat up from the outside of the tank to see how well the methane gas will release off the carbon. As you can see, these are primary heater hoses with engine hot coolant surrounding the tank to warm it up from the outside. It seems to be working well. So we decided that we're going to take the step further and efficiently try to heat up the carbon and methane inside the tank. Well, this is still considered generation 1. On one end, we have a cooling unit to help absorb the natural gas, methane, to the carbon. And the other end is a heating element inside. It's called a heating rod to heat up the inner core of the tank to release the methane of carbon. That's generation 1. Generation 2 is using a magnetron, a dielectric heating element to induce radio frequency to heat the inner core of the carbon. This is generation 2 using the magnetron.
Generation 3 is going to be when we have a conformable tank and using the dielectric way of heating the tank. You can heat it up very quickly or turn it off and let it cool down very quickly. A couple of our strategic partnerships, one of them is Cenergy 2, who has really helped us, assisted us in getting to this point with our technology. They have an activated carbon that is manufactured and processed that works extremely well for methane storage. They have helped us along the way to get to where we're at. We're also working with CPII, an international microwave and communication company that is working with the technology we have to use radio frequencies and dielectric heating to heat the carbon up to get the methane to release. Other companies that we've worked with, Technocar, Luon Energy, Rotorex, other companies that have been out there and assisting us and telling us, how we can improve things to make our vehicles run better on ANG. At this point, our natural gas tanks are coming from a couple different companies that are manufacturing them, and they are assisting us with these ANG tanks. In the beginning, when I first saw this technology work, and that is where you take an empty tank and fill it with methane gas, and then you take that same tank and fill it with activated carbon and store more gas in a tank that's full than one that's empty, was just amazing to me. And to see the results that we were getting from an engine, an 8.1 liter, which is the largest GMC engine ever built, and being able to run under load in many different circumstances with this system was just, hard to believe. I'd have to go back and reevaluate the tests, redo the tests, and sometimes have to pinch myself and say, this is really working. And it does work. In fact, we're coming out with the first fleet ANG vehicle in the next couple of weeks, to where we're going to be seeing this work in a commercial way. And we're also offering it to other fleets who meet qualifications so that we can have them test and show to the public that this actually does work. This technology is game-changing. It's going to make it so that we can get vehicles off of gasoline and diesel. It's going to make it so that our air is easier to breathe. It's going to solve some of the issues that have to do with global warming. It's going to make us energy independent, not just us, but other countries. Stop sending money overseas. This technology, as the Chinese representatives who came to see us said, this was the bottleneck. Unstop this bottleneck and the world will benefit from it. We feel that this particular technology is ready to go to market, and that is what we intend to do in the near future.